Today we're going to look at nomenclature, and I have it split into two different lessons. This first lesson is going to look at notations with nomenclature. So in order to get to the notation part, we want to first understand and know what nomenclature really is. So as you can see here, we have a variety of different pictures, and these are pictures of things that you would recognize and that you might see in a day-to-day basis. And in everyday life, we have all kinds of categories and names that are constantly used. For example, here we know that this bear is a grizzly bear compared to this one is a black bear. And they're both bears, but they have a different name based upon how we have categorized them and given them names. For social media, if you see this blue bird and you see this camera, you know that it's Twitter and it's Instagram. And so just by their symbols, you know the difference. And then also as you're driving and you see various signs with where to go or on doors of buildings, if you're trying to get in somewhere, you know who employees are and you know who customers are. And that category tells you if you can or can't go there. In chemistry, we have similar things with names and categories. And so here you see some examples. We have carbon dioxide that is written like this as its symbol, but then we also have its name, carbon dioxide. You can see that looks different than this third example where you got copper 2 nitrate and how we write its name. So there's all different ways that we write these names, and there's a reason behind that. And that's what we're going to look at with nomenclature. What nomenclature actually is it's a way to categorize and group different elements and different compounds. And we use it in order to be able to know what we're using. Are we using an ionic compound? Are we using a covalent compound? What can we expect to happen with the electrons in that compound? So there's a variety of things that the name will actually tell us about it. Now just a quick review here with our periodic table. We have these various groups. Groups are the vertical columns that go up and down. And the groups tell us how many electrons are in the outer valence shell. And then we also have the periods that go across, and those tell you how many valence shells we have. So the groups are going to be important for us in order to figure out what charges will be when we get to naming different ionic compounds. But like I said, in this video, we're just going to be looking at nomenclature notations. So there's two different notations that we want to consider. The first one is a subscript. The subscript is going to be the smaller little number that is right after an element. And what happens with that subscript is it's going to refer to the number of atoms for that specific element. So for example, here we got a 2 following the N for nitrogen. So we have 2 nitrogen atoms. That's what it tells us. Just like here, how this 4 subscript, it follows the Cl. So that tells us that we have 4 chlorine atoms. That 4 does not apply to the nitrogen. It only applies to the element that it directly follows. In this first example, you'll see that there aren't any number subscripts. And when there's nothing that's there, in the space that would be a subscript, we assume that there would be 1. So in this case, we would have 1 carbon atom, and we would have 1 oxygen atom, and that would give us our carbon monoxide. Go ahead and try this example down here. Pause the video, and then you check the answer. If you gave it a try, hopefully if you check your answer, it matches up to what we have here. The other notation that we have is a parentheses, and the parentheses is similar to the distributive property in math class. The parentheses is going to distribute the subscript to everything that is in the parentheses. So for example, here we have a subscript 3 that's inside the parentheses, so that subscript only applies to the element that it follows. But we also have this other subscript on the outside of the parentheses of the 2. And that subscript is actually going to be distributed to both the oxygen and is going to be distributed to the nitrogen. So it would mean as far as our total amounts. Let's erase those lines there. Okay, so in this case we have copper, and copper does not have a subscript after it, nor is it in the parentheses. So then we just assume 1. So we'll write that as 1 atom. For the nitrogen, It is followed by a 1, assumed 1 subscript, but it's in the parentheses and the 2 is outside of it, so we have to distribute that through. So that would be 1 times 2. So we have a total of 2 atoms there. And then for the oxygen, we have the 3 times the 2. So we'd have a total of 6 oxygen atoms. Okay, let's look at this next one here. Aluminum, it's outside of the parentheses and it has no subscript, so we assume 1. For oxygen and hydrogen, those are both in the parentheses, and so this 3 that's on the outside is going to be distributed to both of them. Now you can think of it individually as our oxygen has 3 atoms, or our hydrogen has 3 atoms. Or in this case, the OH, the hydroxide, is actually a polyatomic. So if you even wanted to just put that the polyatomic, we had a total of 3 of those, you could. Go ahead and pause the video and give this last one a try before you check your answer. As you check your answer, hopefully you have what matches up here as well. That concludes the nomenclature notations with the parentheses and the subscripts. If you need extra practice on that, you can check the website to get some more problems, and then go ahead and check out the next nomenclature video that is instructing you how to name and write compounds. I hope that was helpful. Have a great rest of your day.